Hello, this is Brian Kinghorn, and I'm going to tell you about the multiple end uses feature in MateCell. And you use this to bring some planned structure into your breeding program to help you target your diverse customer needs as well as your own needs. And of course, your own needs are largely to do with having sustained long-term genetic progress in your nucleus population. So what are end uses? These are the different uses of your improved genetic material, typically different customer trait requirements. So if you've got some useful genetic variation for resistance to a particular disease, you don't want to be sending the most resistant individuals to customers who are in a disease-free environment. Likewise, you might have some customers who are targeting markets dominated by high marbling beef versus hamburger mince. And what the multiple end uses feature does is help you to organize the distribution across traits so that you can do a better job of satisfying these diverse customer needs. Other examples relate to the different roles in industry. So you may have bulls that are destined to be used for crossing over Angus cows versus Brahman cows. And the key different roles in industry are the elite nucleus breeding animals in your own nucleus and possibly the nucleus of others who buy from you, as opposed to multiplier and dissemination populations. And these may differ in terms of trait requirements, but that's not necessarily the case to make good use of the end uses feature, and I'll give an example of that later. The key end use, which we number end use 1, is the nucleus, and that was the one where long-term genetic gains are required across all customer needs. And here's a nucleus that's producing young stock, and these young stock are either selected back into the nucleus or they are culled, or indeed they are disseminated to customers. In this example, customer 1 is targeting a market that requires large carcasses, and customer 2 is targeting a market requiring small carcasses. And so there are difference in trait requirements between the customers. And here's an even bigger difference in trait requirements when customer 2 is focusing on the production of young females for sale into the industry. And so customer 2 needs good maternal properties in the bulls that he or she buys, whereas that's not the case for customer 1. So quite a big difference required there. In this simple example, we're just looking at dividing the animals into different categories, whereas the multiple end uses feature does more than that. It looks a generation ahead, essentially. And to illustrate that, I'll use an example from trees. And the different types of trees here are furniture orientated with straight trunks, fast-growing pulp types, and an intermediate type. So we look in the top row here, we've got nucleus-generated candidates. They've come out of the nucleus breeding program, and we want to divide them into 3 categories, that being those that are going to be selected back into the nucleus, typically because they're better genetically, although that might also be because of their attributes to do with genetic diversity. Then we've got those that are going to be used in the furniture industry and those in the pulp industry. So essentially these trees are going to be grown to produce seed for going into those different industries. Of course, it may be if the industry is small enough and the nucleus is big enough, that seed can come out of the nucleus, but in many industries, some kind of multiplier level is required, and that's what's illustrated here. So the furniture industry is made up mostly of straight trunk and intermediate types, whereas the pulp industry is made up mostly of the pulp type and the intermediate type. We want to do a better job of more accurately assembling groups which are destined to be used in the furniture and pulp industry. So what we do is, rather than just make selections, we make selections and matings and generate a new generation where we have a better chance of doing that. So this slide's not directly comparable, but I've laid it out this way for illustration. So if I go back to the previous slide, you can see that we don't have so much specialization in the furniture and pulp industry categories. But if I go to this generation, we see we have done something in the mate selections in order to do a better job. If I jump between the 2 slides, you'll see I've suggested that the nucleus is unaffected in terms of its distribution, and that can largely or even totally be the case when you're using the multiple end uses feature. So to more accurately represent what's going on here, let's just jump ahead. So this top row is the same as the top row before, and the bottom row is the same as the bottom row in the previous slide, but I've shown the progeny that are generated out of these matings here. So we have the parents, which are the nucleus-generated candidates that have been selected and mated, their progeny, and then we have the sorted progeny. And there are 2 ways that we're making progress here. One is by having a set of progeny which are better set up for you to make the division into these categories. And of course, the second part is the dividing of those progeny into these different categories for the pulp, furniture, and nucleus components. So just to summarize that, at the stage that we're making selection and mating decisions, we accommodate not only targeting a good nucleus population, that we also look for dissemination. An important point to note here is that in setting up these specialized matings for pulp and furniture industries, you are not pre-deciding the fate of the progeny that come out of these matings. What you're really doing here is setting up the outcomes so that you have more opportunity in the future to make the split between these three different end uses down here. For example, a mating that comes out of this furniture matings may produce progeny that once they're evaluated and their EBVs are seen, they may warrant inclusion in the nucleus. So you are not pre-deciding the fate of those matings. A simple way of looking at multiple end uses is to consider genetic merit of the candidates on a single scale. There's a truncation, which of course in real life would be optimal contributions, but just for representation, some individuals are culled. The head of the breeding program is targeted very much at your nucleus gains. With the tail of the breeding program, we take the opportunity to diversify the matings and selections in such a way that we have a better opportunity to satisfy customer needs. And yet, of course, matings made at this end of the distribution may well end up providing progeny that are used for selection into the nucleus. Now we'll go on to look at implementing multiple end uses in MateCell. The first thing you do is in the file matecell.ini set the switch to control multiple end uses to 1. And that means that when MateCell runs, it expects to find a file EndUses.txt, which I'll show here. But let's go to the PowerPoint and look at that in more detail. So in this case, we've got 3 end uses, and these are targeted at the nucleus, specialty wool, so this is obviously sheep, and specialty meat. So these are the 3 end uses here, 1 row per end use. In the columns, we have weightings for the traits over here, and these are typically a relative economic weighting for each trait. However, the first column is dedicated to the index as supplied in the data file. And this is a way of just simply using that index, in this case for the nucleus index. But we've customized indices giving higher weightings for wool traits under specialty wool and higher weightings for meat traits under specialty meat. This row tells you the number of matings that you want to target for each end use. And this is an important row here, which gives a relative weighting for each end use. And typically you will have the highest weighting for the nucleus, which means that it will essentially get the pick of the crop for itself. And that it would only be under exceptional circumstances with the weighting shown here that there would be much compromise from the nucleus getting the best stock available to it. So if you want to let your customers have some higher priority compared to yourself, you would put higher weightings here, but probably do a bit of a research program to investigate how much compromise you're making from that. So these indices are not used within MateCell exactly as you see them. They are scaled from 0 to 1, make it possible for them to compete with each other on the basis of the weightings that you deliver here. Now we'll move to a short demonstration running MateCell, and we're just going to use exactly the same version of that as comes distributed with MateCell. In this case, I've got a very simple scenario. End use 1 is selecting on the index alone. End use 2 is targeting the first trait, which is the second column. And end use 3 is targeting the second trait, which is the third column. The total number of matings is 50, and that's distributed 20, 15, 15. And I'm prioritizing the nucleus as would be normal. So here's an example that has been running. If we click print matings, then we'll get end use column showing us 20 end use matings for our end use 1 and 15 for each of end use 2 and end use 3. An important thing to note here is that the frontier is drawn completely from end use 1 matings with no involvement of other end uses. And that's because it's in the nucleus that we want to manage diversity, and that's what this is all about on the frontier. Now, a convenient place to look and see how you're doing with your end uses is in the file outsummary.txt. That's just been updated. And at the bottom of that, when you're using end uses, you'll see the results for end use 1, 2 and 3 in this case with this number of matings. And you'll see for end use 1, the index at 108 is higher than the other 2 end uses, which is what you expect. And for end use 2, birth weight is 1.06, which is higher than the other 2, and that's essentially what we asked for. And for end use 3, yearling weight is highest, 114 units, and that's what we asked for there as well. So let's make a change here, go back to this example, and I'll target 80 degrees. And what we see now is that in fact end use 1, the nucleus, has got a lower index than either of the other two end uses. And that is because we are putting a great deal of emphasis in the nucleus on diversity and thereby accepting lower EBV individuals as parents in order to achieve that. So this is an example where you may even have higher genetic merit being disseminated to your customers than you're using in your nucleus, where in an extreme case you would be targeting very high diversity. Not typical at all, but this is illustrative. However, you will see that for end use 2, trait 1, birth weight does well, and for end use 3, yearling weight, trait 3, does well as we have asked for. So now we'll go on and look at a small example from the published study. And this uses the same examples we've had in the slide with 3 end uses: the nucleus, terminal customers, and maternal customers. And the study is here. I'm going to treat this graphic quickly, but you can pause and look at it again to get more understanding perhaps. So we've got the nucleus index, the terminal index, and the maternal index here. And within each of those, we've got the groups of animals. The nucleus animals, these are uncompromised by selecting with high priority into the nucleus. Without multiple end uses, the results are in this red bar. With multiple end uses, we have the terminal in green and magenta for the maternal results. So if we look at the terminal index, the individuals that are sent to terminal customers with no multiple end uses are here on the red bar. And if we use multiple end uses, the animals that go to the terminal customers are this much better. Likewise, if we look at the maternal index, this is the value here of those that would be sent under no multiple end uses. And with multiple end uses, we have distributed the mating such we've got better opportunity. Now, these results depend on how good a job you do at making the selections into the different groupings, and that's described in the paper, but I think you can see there's some considerable benefit to be had by setting up the matings a generation before in order to get this result. Now we'll look at a case where we can use multiple end uses for the same objective without different traits, and this example is inspired by a slide from the committed matings video. So if we need to use eggs from these salmon or prawns from all females to satisfy dissemination and sales, or maybe a certain proportion of these females, higher than we need for the nucleus, then we can use 2 end uses, nucleus and dissemination. And the text file might look something like this. And you'll see that both of these end uses are heading for the normal index, and that we're looking for 23 matings to go into the nucleus, 77 for dissemination, and anything that's left over would be culled, and that could be 0 in terms of numbers, with priority given to the nucleus. Now, if you had a total of 100 matings, then you might be as well just to do a simple mate cell run and select just the 23 best matings and use all the remainder for dissemination. However, with this setup, what you can do, of course, is change the character of the disseminated individuals by having a separate set of index weightings for them. Moving on, let's look at other applications. Simultaneously target different pathways in dairy. So you could be looking at for elite matings and commercial matings. And in the commercial matings, you would not have an interest in diversity to the same extent, or for different reasons perhaps. And that might be challenging in mate cell because there are so many commercial matings. However, there's a trick to handling that, which I'll show you quickly here. And that is that we can consider that animals that are generated by the nucleus that can be disseminated might be used in commercial farms that have got different end uses, such as crossbreeding, tick resistance, etc. What we can do is simply enter these in the data file as females requiring a very large number of matings. So farm 1 requires 500 matings, and it's a single female as far as mate cell is concerned, and likewise for the other farms. Then when we do the mate cell run, we can have dissemination across all those different commercial entities, balanced with decisions about use in the nucleus. So the 2 purposes for showing in this slide, one is to show that there is a different way of doing things if this is what your scenario looks like. And the other is that for situations such as we're discussing here with very large number of matings, you can group matings according to farm or region or whatever. And you can read about this under tips and tricks in the manual. Another use for multiple end uses is as a prelude to splitting breeding lines. And this graph tells you something a little bit about that from the video Managing Trait Distributions, Should I Manage My Traits? And so it is possible that you might start to use multiple end uses so that you're in a better position after a number of years or generations to make the hard decision to split your breeding line into 2 or more directions. Another application is to make resources for specific research, such as generating high and low selection groups, or maybe you want to do a particular test as to how well certain animals or certain categories of EBV perform in certain aspects of your operation. And lastly, we'll look at grouping and tricks. The thing here is that you can use both grouping and multiple end uses simultaneously. These are both ways of categorizing animals, but the key difference is that for grouping, you do the categorization and you include that information in the data file. Whereas with multiple end uses, MateCell does the categorization and you don't have to include any information in the data file. However, these two things are disjointed. For example, you cannot specify that end-use2 matings must come from group 2 males mated to group 3 females. You can't specify that, but you can push for it. So what you do in this example would be to make an extra column with only group 2 males, or possibly a subset of group 2 males having a positive value in there, and the same for group 3 females. So then for that trait, which is a dummy trait you've entered into the data file, you put a big weight on that trait for end use number 2. That way, end use 2 will attract group 2 males mated to group 3 females. Another thing you can do is to consider use of non-trait traits such as age and location. So for example, you might want to make certain types of matings with certain trait profiles, but only that they come from certain age animals, like older rams with younger ewes or vice versa, and that you only want them to be taking place at some location that you've got within the operation that is being run by MateCell for this run. I'll end with a comment on convergence, which can be slower under multiple end uses. We're not just selecting individuals into different end uses, we're mating like with like in order to give concentration of trait profiles into these different end uses. And that means that multiple end uses depends heavily on mate allocations, and that's more computationally demanding. So when you're using multiple end uses, pay particular attention to convergence and make sure that your job is well converged before you accept the results. Well, that's the end of this video. Thank you for listening.